Hello everybody. In this video series, we're going to calculate arc length in polar form. Our formula to find arc length in polar form is integration from alpha to beta square root of r squared plus dr d theta squared. Here r squared is our radius and dr d theta is the derivative of the radius. Let's start. In our first example, our radius is 3 cosine theta. So we need to find the derivative of radius. So the derivative of radius is negative 3 sine theta. Now we're going to plug in our r and dr in the formula. So length equals to integration from alpha to beta. So our alpha is 0, which is our lower boundary, and our upper boundary is pi over 4. Square root of r squared, which is 3 cosine theta squared, plus the derivative of radius squared, which is negative 3 sine theta squared d theta. Now we're going to square both r and dr d theta. Integration from 0 to pi over 4. 3 cosine theta squared is 9 cosine squared of theta. Plus 3 sine theta squared is 9 sine squared theta. Now we can factor out 9 here. So 9 factored out. What is left inside? Cosine squared theta plus sine squared theta. This is our Pythagorean identity. Sine squared theta plus cosine squared theta equals to 1. So this quantity equals to 1. 9 times 1 is 9. So let's continue here. Integration from 0 to pi over 4 square root of 9 d theta. 9 goes out of the radical sign as 3, so integration from 0 to pi over 4 3 d theta. So what is the antiderivative of 3 with respect to theta? It is 3 theta evaluated from 0 to pi over 4. Now we're going to plug upper boundary, which is pi over 4, minus lower boundary, which is 0. And if we distribute 3, we get 3 pi over 4. So this is the final answer.